Hello, Science 9. This is Mr. Chan. And what I wanted to do today is I wanted to work on the second part of chemical naming. Now, in the last video, we talked about naming ionic compounds, and you notice that we followed the same pattern of finding the charge, finding the lowest common multiple, and then multiplying, finding the numbers that we multiplied by. And recall, it's the multipliers that become the little numbers that we put in the chemical formula. So I gave you a couple of examples with what we call monovalent, or those elements with one charge. And then I talked about chemical naming. What happens? How do we name chemical formulas? Remember, we have the IDE ending. All right, so we change the chlorine to chloride to indicate that it is now joined, like nitrogen is now nitride. And then we talked about multivalence. So those with more than one charge, like copper 1 and copper 2. And remember, we had to use Roman numerals. So in this case, the copper 2 oxide, the 2 told us that we need to use a charge of 2. And when we name with multivalence, remember, we don't just go iron nitride. What we have to do is check to see what charge did the iron use, and we put the Roman numerals right beside the metal, which in this case is iron. Now, what I wanted to do was today I wanted to finish off with polyatomics and covalent naming. But even though we're adding on, you will notice that we follow the same basic principles of finding the charge, finding the lowest common multiple, finding the multipliers, and then writing the chemical formula using the numbers in the multiplier. So today what I wanted to do was talk about naming with polyatomic ions. Now, what are polyatomic ions is basically, if we have here, we have, we have a group of atoms that stay together and have a charge. Okay. Now, if you take a look on the periodic table that I gave you, what you will notice is, let's see here, if I can get this up here. Come on. All right. So if we take a look at the periodic table, polyatomic list, the polyatomic ions is this list down the right-hand side. So what this is a group overall charge. So what that is that it has one carbon and 3 hydrogens. They're grouped together, and it has an overall charge of -2. Let's say we had something like nitrate. So nitrate is just 1 nitrogen, 3 oxygens, and overall it has a charge of -1. And you will notice that the majority of the polyatomics, they end off in either ATE or ITE endings. So going back to our notes, so when we go from a chemical name to chemical formula, we use the exact same process as with 2 elements. Okay, we still will use the same 4 steps: charge, lowest common multiple, multiplier, and then writing the formula. So let me give you an example here. So let's say, for example, we had, let's say we had sodium phosphate. Now, if we have sodium phosphate, what happens is if we, again, write the charge, write this little table, and we have the charge, the multiplier, and the LCM, lowest common multiple. Again, it's the same process. Sodium, you recall from looking at your periodic table, if we look for sodium, If we had sodium up here, again, standard. Okay, whoopsie. Sodium is a charge of +1. All right, and if we do that, so here would be a charge of +1. Now, phosphate, if you take a look on the back side of your periodic table, under this polyatomic list, if you scroll down, you see phosphate is right here. So phosphate is 1 phosphorus and 4 oxygens, and overall it has a charge of -3. So if we go up here into our formula, so here the phosphate would be -3. And so again, the lowest common multiplier is 3, lowest common multiple is 3. And then so here would be ×1, and sodium would be 3. And so what would be the formula? Would be Na3. So because of the 3 that's here. And then we would have PO4, because that's the formula for phosphate, and with a 1. Now, to help you out, you can keep the brackets around it, even though there's a 1. But to clean it up, you can write it out as Na3PO4. Okay? So that's something that you can try out. Okay? Now, another one we can try using multivalent would be something like, oh, I don't know. Let's have manganese 4 nitrate. Now, with manganese 4 nitrate, okay, you have your charge, your multiplier, your lowest common multiple. The manganese 4 means that you have a charge of +4. So here you have the 4, it's a +4. Nitrate is, nitrate, if we look down nitrate here under our periodic table, polyatomic list, okay? So if we look for nitrate, nitrate we have is a group NO3, and it has a charge of -1. So in this, if we look back here, nitrate would be, in this case here, would be -1. Again, lowest common multiple is 4 and 4. So this would be ×1. This would be ×4. So what would the formula be? In this case, it would be Mn1 brackets NO3 brackets 4. Okay. Again, where's the 1 come from? The 1 is from the multiplier, and then the 4 for nitrate is here. Okay. Now, for chemical names, from chemical formulas to chemical names, one needs to recognize the polyatomic ions. The ending of the polyatomic does not change. And remember, if the metal has more than 1 ion charge or is multivalent, you must use Roman numerals in the name. So let's say if I gave you an example here. Let's say we have MgSO4. Now, how can you recognize if there's a polyatomic? Notice you have the elements Mg, S, and O. Because you have 3 elements, so therefore, you have polyatomic. Okay, now usually the polyatomic is the negative, okay, negative ion. So in this case, you would recognize Mg here This would be magnesium. And you recognize here SO4 is your polyatomic. So looking at the list of your polyatomic ions, what is SO4? If you look here, you have SO4 is sulfate. Okay, and so what you have in this particular case is in here would be sulfate. So it's magnesium sulfate. Okay, that's pretty straightforward. Now, let me give you another example. Let's say we had Fe, oopsie, Fe, let's say NO3 brackets 2. Now, again, the first step you do is you notice you have Fe, you have N, and you have O. Again, you have the 3 elements. Okay, now again, so therefore, polyatomic. Now, again, just like what you had done up here, you recognize that this is iron. And in this case, the NO3, if you look at your polyatomic, okay, you will notice that the NO3 is nitrate. So here is, this would be nitrate. Now, again, what you need to do is you need to look at iron. And if you look at the list on iron here, see the polyatomic list. So you notice iron has a charge of either +2 or +3. So that means since it has a choice, you have to use Roman numerals. So in this particular case, oopsie, oh, why is this one all the way up here? That's okay. So what we need to do is scroll back down here. So sorry. Okay. So now we need to set it up again. If you're setting up the iron and the nitrate, here would be the charge, the multiplier, and the LCM. So nitrate, you know, is -1. How did you know that? Again, is if you look at the list, polyatomic list, nitrate is -1 right here on the right-hand side. All right. So here would be -1, and iron is either +2 or +3. Now the multiplier here is 2. How did I know the 2? Is because of this 2 that's on the outside. So what you have here is you have that 2. So now -1 times 2 is 2. Again, don't worry about the negative or positive. So for iron, the LCM must be 2. So here, how many irons did I have? I multiplied it by 1 because there is no little number. So what times 1 gives you 2? The answer would be 2 here. And cross out the +3. So this would be iron 2 nitrate. Okay. Again, this is just an extra step in terms of if you have metals that have choices. So the one up here with magnesium sulfate, I didn't have to do that because magnesium only had one choice. Now, if you take a look at the examples, exactly the same thing. Just like last lesson, where you had to go back to figure out the charges. Okay, but you notice it's still the same process. Step 1, find the charge. Step 2, find the lowest common multiple. Step 3 is the multiplier. And step 4 is the formula. All right, the last one is covalent bonding. generally occurs when two elements or two nonmetals combine when forming a compound like CO2. Now, the nonmetal that's further left or further down on the periodic table is generally written first. Now, so what do we do? So for two elements, okay, for when we do covalent compounds, two elements to chemical formula to chemical name is exactly like ionic bonding. Let me see here, okay? So what you use is use the ion charge to determine the formula. So let's say, for example, here, let's say I had nitrogen and oxygen. Okay, now we set this up exactly the same thing. Okay, so here we have the charge, the multiplier LCM. So nitrogen, again, if you take a look on your periodic table, it is -3. Oxygen is -2. So the lowest common multiple is 6 and 6. So this is times 2. This is times 3. And so what we get is we get a formula of N2O3. Okay. Now, when we look for the name of N2O3, okay, it says here, for a covalent compound, one needs to use prefixes to identify the number of atoms in a compound. So in this case, notice I've given you a list of the numbers, like the Greek prefix. So number 1, the Greek prefix is mono, number 2 is di, number 3 is tri, and so on. So in this case, for nitrogen, for this particular formula, what it is that it is dinitrogen, oopsie, nitrogen, trioxide. So why is it dinitrogen? Because the 2 is the di, and 3 for the oxygen would be tri. Okay, so in this case, what you want to do for covalent compounds, okay, or nonmetals, what we use is we just use these prefixes, di, tri, and so on. Okay, did I have it here? Okay, so for this case, another example would be, let's say if I had, you know, P2, let me see here. Okay, so in this case, let's say if I had something like, I don't know, P2O5. So what that would do is it'd be diphosphorus pentaoxide. Okay. So 2 would be the di, and in this case, the 5 would be the penta. Okay. Now, for chemical names, the chemical formulas, the prefixes tell you the number of atoms in that particular formula, so you don't need to worry about ion charge. So let's say if I had monocarbon dioxide, the monocarbon means that it's C1. Dioxide would be O2. The mono means 1. The di means 2. And so this is where we get the word with the formula, CO2. The more common name is carbon dioxide. Now, sometimes in this case, you can say here, the mono is not written for the first element. And the key word is the first element. You could write it at this point in time, you can write it as monocarbon dioxide, and that's perfectly fine. But you can also say carbon dioxide. So for covalent naming, in some ways, it's actually simpler. All we need to worry about is the prefixes. Okay, so for covalent naming, you have two nonmetals. You still just follow the 4 steps: the charge, the lowest common multiple, the multiplier, and then the formula. And to indicate that you have two nonmetals, what you use is you use prefixes in the names. Now, remember, for metals with multiple charges, we have to use Roman numerals. So that's the key difference. We're not using Roman numerals for covalent bonds, but we are using prefixes. Okay, hopefully that's clear, and hopefully that summarizes some of the stuff you should have learned in class. Again, if you have any questions, feel free to come see me during flex time for clarification. All right, folks, thank you very much. Have a good day. Bye-bye.